Hey guys, today we are going to be going over the paired t-test. So first we'll go over what its uses are. The most important use is that it can reject or fail to reject the null hypothesis. It's a very important distinction. You cannot confirm the null hypothesis. What is the null hypothesis? So this is the most common example of a null hypothesis, and it basically says that the population mean of one group is equal to the population mean of the second group. And what that really means is that there is no difference in the means between these groups. So whatever experiment you did had no effect. The t-test can also be used for things like confidence interval, but we're not going to go over that in this video. When is it appropriate to use the paired t-test? So first of all, the data set must be paired, and what that means is that you're collecting data on the same samples multiple times. So an example of that would be like you take data on the same person before and after they go for a run. It's the same sample. And usually the number of samples has to be small. A good guideline is the number of samples is less than 30. If it's significantly greater, I would recommend something like the z-test. And the t-test also assumes a normal distribution and that the variations for both populations are about equal. If this isn't true, then the t-test just won't be doing as good of a job as it could be. So the first part, in order to calculate the t-test, is to calculate the t-statistic. Using this equation, t is equal to the average of the differences divided by the standard deviation of the differences, where n is the number of samples. So the last part of using a t-test is reading a t-table. There's a few bits of information you'll need to know for that. First of which is the degrees of freedom of a data set is equal to the number of samples minus 1. Then you'll need to decide whether or not you're using a two-tailed or a one-tailed test. You use a two-tailed test in the event that you're not sure how your experiment affected the data points, either positively or negatively. You can use a one-tailed test only if you are absolutely certain that your experiment either increased all the data points or decreased all the data points. And so if it's a two-tailed test, you use uncertainty value, which is generally going to be 0.05 divided by 2, but for a one-tailed test you can just use the alpha value. Don't worry, we'll be going over an example of how to read the t-table. And how you draw your final conclusions is just if the t-statistic is greater than the t-table value, you can reject the null hypothesis. Alright, so now we'll go over an example for calculating the t-statistic. Our first step is to calculate the difference between these two data sets. So we'll just do this cell minus that cell, and for Excel you can always just drag and it'll carry all the calculations down. Now we find the average of those differences. Equal to that, and then the standard deviation of these differences. So for this one, we definitely want to use standard deviation of a sample, not standard deviation of a population. So choose standard deviation .s and select these. Alright, so now we calculate our t-statistic, which, if we remember, is the average of the standard differences divided by the standard deviation of the differences, which is then divided by the square root of the number of samples. In this case we had 10. So our t-statistic becomes 1.921. So this is a t-table. You guys can just look one up online. But on this left side here we have degrees of freedom, and up top we have the alpha values. So for our example, our degrees of freedom is 9 because our samples was 10. And we're going to say that this is a one-sided test, so we are going to use this 0.05 value. Look on this table and see that our number is 1.833. So our t statistic was greater than our t table value, which means that we can reject the null hypothesis.